All right, guys, here we go. So this is NSCA Essentials of Personal Training. This is Chapter 11, and we're talking about fitness evaluation protocols and norms. And I mentioned in my previous presentation, you can kind of broadly categorize what's on this left side of the page here in the book, that you have evaluations or ways we evaluate the person, and then you have ways we evaluate the performance of the person. So this first presentation will just be about vital signs and body composition. I won't be speaking regarding training load in this presentation. I'll do it in a separate one. It's going to be mutually exclusive from this. But roughly, we're starting off on page 197. We're going to make our way through 211. And this is all stuff you've done before, but I definitely want to touch base on a few things and go over a few takeaways that you should have. When we talk about resting heart rate and you evaluate resting heart rate, you're going to do so when the person is rested, they're in a resting state, and the person you're going to work with, when you go ahead and do their resting heart rate, preferably you'd like to have them do their resting heart rate right in the morning, right when they wake up. But oftentimes you do an intake, you work with the person, you're doing resting heart rate, or they have a wearable on their wrist, and the resting heart rate you take is the one after they've driven in traffic to get to you at 5 o'clock in the afternoon. And it's not exactly accurate, but you got to understand there's three main categories. One is bradycardia, the other is normal sinus rhythm, and the other is tachycardia. Normal sinus rhythm is denoted here, of most adults having between 60 and 80 beats per minute, whereas tachycardia is above that, and you'll be about 100 beats per minute, and bradycardia is less than the 60 to 80, and you end up having, it's actually less than 60, I should say, be more accurate. So if you think of it like on a continuum, anything leading up to 60, bradycardia, anything between 60 and 80 would be normal sinus rhythm, anything above 80, and specifically the book here notes anything above 100 beats per minute would be tachycardic. And you'll rarely come across people who will be above 100. You might have some people who are endurance athletes or just have the ability to control their heart rate, and they can end up having a lower heart rate. But usually at 60 to 80 is where you're going to find most people. You'll take pulse either on the wrist, on the neck, as noted here. If they talk about the brachial artery, the radial artery, the carotid artery, and the temporal artery, and really at the end of the day, you'll probably end up taking this more on the radial artery over by the wrist itself. And more often than not, what you see now is we get out of analog and we get into digital, and you'll have a pulse oximeter that you're going to slip on the person's finger and it'll take their pulse, or they have a wearable and you take their pulse that way. But this is the process you would use if you were going to go ahead and do this in a clinical environment. In taking the pulse itself, things you have to watch out for is how hard you actually push if you're going to go ahead and press. So like this in figure 11.1 up here, if you're pressing too hard with your fingers, you can actually push and occlude or put too much pressure on the actual artery, and it'll end up changing the actual pulse rate. Same thing up in the neck. If you go ahead and do the carotid, you just have to be precise in terms of how much pressure you put in or utilize when you're taking heart rate. So a couple things they note here in terms of factors that affect heart rate: smoking, caffeine, environmental, things that you should probably have yourself acquainted with before you take the test itself, because those are things will have an effect on the actual outcome. All right, so if we go ahead and bump this over, we go into blood pressure. Blood pressure is another very commonly taken or very commonly utilized assessment. But the book itself, notes that blood pressure can be defined as the forces of blood acting against vessel walls. The sounds that are emitted as a result of those forces are called Korotkov sounds. And you have different, if you will, qualities to those sounds. And when you have a disappearance of the sounds under pressure, like when you have an actual sleeve on, that's going to then tell us what the person's blood pressure is. And um, much like the heart rate example, where we've kind of gone more digital with this, you'll more than likely have a blood pressure cuff attached to a machine, put the cuff on the person, you tell them to relax, they take a couple moments to relax, and then you push the button and off you go. But if you don't have that, what happened is you'd have a manual cuff with an air bladder that you would pump up, and that cuts off the circulation or the blood flow to the artery. You have the stethoscope, and that's placed in the cuboid fossa, which is down kind of where the bend of the elbow is. And as you release air from the cuff, then you listen for the sounds going through the artery. And that's how you take blood pressure. We practice this in depth in our other class, so I'm not going to belabor the nuances of how to actually take it here. But again, what you'll find usually when you get out of a more clinical setting and get into a more practical setting, you're going to find that it's probably more digital than analog, and it's going to be more put the cuff on in the right place, in the right way, and push the start button. And then you're left to describe the results more than anything else. So they mentioned a couple things that affect blood pressure assessment, much like heart rate, smoking, caffeine, stress, other medications will also have an effect. And they talk about little nuanced things over here, like common errors. You put the earpieces in backwards so you can't hear, or perhaps you're not at the right eye level to be able to see the dial. The actual stethoscope or the bell of it is tucked underneath the cuff, so you're getting background noise. A pretty common one too that you see is people will put their thumb on top of the bell of the stethoscope, and what ends up happening is, your thumb will end up having a little bit of background noise from its own little pulse in the stethoscope, because sometimes it's hard to differentiate. You're better off taking your two fingers, and if you put your two fingers on either side of the bell as opposed to putting your thumb right on the middle, that usually works out a lot better. All right, so I'm gonna let you guys review all this stuff, but just realize those are kind of the main takeaways. And when they talk about normal blood pressure and measuring blood pressure, and you look at not the examples here, but the actual data points and the charts that they provide for normalized data, it becomes a conversation of how do you explain this to your client? What does 120 over 70 mean? What does that top number mean? And you have to be able to describe to them that, the number on top is the force applied when the heart squishes, and then the number on the bottom is when the heart relaxes, and you have to be able to explain this in layman's terms so your people understand that, well, 110 over 70 is great, but 180 over 90 is probably not so good. And you have to be able to guide them in terms of understanding what those numbers mean. Now, if I take this a little bit further, I'm going to go past training logs. We'll talk about that here in another presentation. And we get into body composition. Body composition is another series of assessments that we use to be able to evaluate the state of the person. If we look at body composition, again, I'm kind of turned off by the fact that the book tucks anthropometry into body composition, but let's just go through it. When we look at anthropometry, it's a science and measurement of applied to the human body, and it generally includes measurements of height, weight, and selective body girth. So that's not really body composition per se and how our bodies are made up, but I'm just going to roll with it. They talk about how to actually measure people's height, et cetera, which is stuff we don't need to get into here. BMI itself, it's an equation, and you use that equation. That's BMI is kilograms divided by meters squared. So you take the person's body weight in kilograms and you divide it by their height in meters squared, and that gives you BMI. And we know anything above 30, there's a contraindication point there for exercise, or more accurately, on American College of Sports Medicine 8.1 format, we know that that is an issue. All right, so BMI is a tool for us. It's not the best tool, it's not the greatest tool, but it's a tool we use to be able to evaluate the level of fitness for a person. With height, I don't think we need to worry too much about how to actually measure one's height and what their stature is, but just understand it might be a stadiometer, which is if you have a scale, and the scale usually has that thing that flips up that you slide on top of the person's head. If that's what you would use to measure their height. Usually you can do height and weight in one-stop shop, which makes it very convenient. So if we go ahead and bump this over, calculating BMI, that's not anything you have to worry about. weight and body mass. They go into a little bit of a description here regarding the differences. And now when we get into this next one, skin folds, now we're talking more specific to body composition because we're taking skin fold measurements, which measures the thickness of the subcutaneous fat. And we know there's a relationship between the measurements of subcutaneous fat and when we use particular formulas, mathematical formulas, to be able to calculate a person's first body density, but then also their body fatness. And we've done this a ton of times, but just understand that, skin folds have their place in a clinical environment, but oftentimes when you get into a fitness-based environment, you might be using like an in-body and you're doing bioelectrical impedance. But they go in great length here to explain the process and explain, skin fold calipers and how to use them correctly. And, they talk about, lifting up here, lift a fold by placing the thumb and index finger approximately about 3 inches apart on a line that is perpendicular to the long axis of a skin fold. The long axis is parallel to the natural cleavage line of the skin. I want to point out that I seem to remember that one of the test questions, and I'm not sure they rewrote it at this point, but they talk about how it's perpendicular to the long axis of a skin fold. But I think one of the test questions, if I remember correctly, was perpendicular to the body. It's worded funny. There was something funny in that question, but I have that in green because it's kind of specific. They give you the areas, the actual regions where you need to do the skin fold calipers. And we've done this a ton, so I'm just going to go ahead and move on to the next one. Bioelectrical impedance, that's the standing on the scale, or I'm sorry, standing on the in-body or using a handheld Batman steering wheel. And, we talk about fat mass versus fat-free mass, so it's how we calculate that out. And you have to be able to explain that process in terms of how it sends a low level of electrical current through the body. Fat is an insulator. Fat-free mass conducts, and it evaluates and comes up with its body fat number, the percentage, based off of how fast the electrical current goes through the body. That's why it's called bioelectrical impedance. If you look up impedance in terms of electrical, you'll find that it's the rate at which electrical current goes through a wire, and there's impedance involved in that process. All right, waist to hip girth ratio. This goes and takes us away from body composition and brings us back more into like anthropometrics, but there is a ratio between the waist and the hip, and we measure both those, the circumference of each of those, and that ratio allows us to determine if a person is at risk. All right, so with that, I'm going to break off here and then go into my cardiovascular presentation. So I'll be right back. Thanks.